Hello students. Today we will learn about storage and memory devices. Let us first start with data and information. Children, you all know that a computer cannot work on its own. We need to enter certain set of characters and instructions into the computer to make it work. This set of characters like alphabets, digits, or special characters that represent facts or figures is known as data. When this data is processed by the processing unit, that is CPU, it is known as information. Therefore, we can say data is unorganized facts and figures, and processed data is known as information. Children, you should remember that unprocessed data is meaningless, but when such data is organized and converted into meaningful information, it becomes useful. For example, from our day-to-day life, your father bought cloth from the market and gave it to the tailor to stitch a kurta pajama out of it. In this example, cloth can be considered as data, and kurta and pajama can be considered as information. The cloth in its raw form is not useful until it gets converted into some dress. Examples in context to computers. Your teacher wants to find the highest and lowest scores of your class. For this, she inputs marks scored by each student in all the subjects in the computer and gives the required instructions to it. In return, computer displays the highest and lowest scorers of the class. Here, marks that were fed into the computer represent data, and the result returned by the computer, that is highest and lowest rankers, represent information. While booking the railway ticket, you provide the details like source station, destination, date of journey, and number of persons traveling to the computer. This data is processed by the computer and you get the railway ticket. In this case, the details like source station, destination, date of journey, and number of persons traveling represent data, and the tickets which you get represent information. Okay, now let us talk about the data storage units. Whatever we feed into the computer gets converted into a machine understandable code called machine code. A computer can understand only two states, on, represented by 1, and off, represented by 0. These two digits, 0 and 1, are called binary digits or bits. The data is stored in the computer memory in the form of bits and is measured in bytes. Memory size. 8 bits is equal to 1 byte. 1024 bytes is equal to 1 kilobyte. 1 KB. 1024 KB is equal to 1 megabyte. 1 MB. 1024 MB is equal to 1 gigabyte. 1 GB. 1024 GB is equal to 1 terabyte. 1 TB. 1024 TB is equal to 1 petabyte. 1 PB. 1024 PB is equal to 1 exabyte. 1 EB. 1024 EB is equal to 1 zettabyte. 1 ZB. 1024 ZB is equal to 1 yottabyte. 1 YB.